All right. Let's we are still we're gonna, whoops. Um we're still talking data visualization. This is gonna be kind of our starting point and introduction to a lot of data science concepts and things like that. And so we're starting with data visualization. I know with data camp you're getting introduced to R, and we've touched on vectors and lists and functions and I don't know, whatever. Okay. And I'll don't worry, I'll also talk about those things in lecture at some point as well. And again, some stuff will appear in lecture first, and then other stuff will appear in data camp first, and hopefully exposure to some of these things multiple times eventually, when it comes to the point where you got to do stuff on your own, it will you'll be ready and equipped. Okay. Some of you have already asked questions about the final project, and that's very proactive on your part. That's great. I will explain the final project later. You're going to have to form groups at some point. So probably around the third week, I'll have you guys start forming groups. I'll have a sign-up sheet and stuff on like Google Sheets, and we'll create that. You guys are coming to class, and I think having classmates or teammates that show up to class is always good. So continue encouraging you to come to class, and then if you've been sitting. Somehow this happens, and it's like the same phenomenon at like church too. It's just like somehow like this becomes my seat, right? Even though there's no assigned seats in the classroom, it's there's like that one seat that you feel like belongs to you, and then when you come to class and somebody's sitting there, it's like, how dare you? But yeah, if you like your neighbors or whatever, you might end up you can. I don't know. Have you guys met your neighbors yet? Should we take a moment to have you guys talk? No, don't. I don't want to talk to my classmates. Well, you're gonna have to at some point for your group projects. But yeah, probably third week. I'll ask you guys to start forming groups and stuff, and then we'll talk about the projects later. Okay. Anyway, let's get into data visualization. We talked about some of this on Wednesday. This is covered in chapter 2. Today's lecture, I'm like stealing straight from chapter 1 in this book called R for Data Science. In this book, you can also read directly in your browser. I love that a lot of books are now like freely available to read in your browser, which is really great. Okay. It's much better than paying $100 for a textbook. All right. Okay. And then good and bad data graphics in your upcoming homework assignment. I'm going to say find an example of good or bad data graphic. And we talked about Reddit. Okay. All right. We're going to load up the tidyverse. This is the set of packages. And anytime, if you try to run something, if you type in library, tidyverse or library whatever, and then you get an error that says there's no package called tidyverse, or there's no package this or that means you got to install it. Okay, that means you have to download and install that package. But again, that's a one-time thing. You don't have to do it. You don't want to do it within your script that gets run every single time. You just do it once in the console. Okay. Anyway, data visualization. All right, this is just another example. This was a couple years ago. I just went online and I was looking at used cars, and I said, hey, let's look up some used Volkswagen Jettas, and they have different mileages and different prices, and we expect this overall relationship that if a car has more mileage driven on it, okay, its price will be a little bit lower, right? So a car with 80,000 miles, we expect to be sold at a lower price than a car with only 26,000 miles, type of thing, okay? And so I've got mileage and price. We're going to graph that. And this is just, I've created the data frame. This is, what year was the car? All right, and I'm gonna just say like, hey, does any particular observation stand out as being like overpriced or a good value? And again, really hard to answer if you only have these numbers. Okay, if I just give you these numbers, it's really hard to figure out what's the answer as far as like, are any of these prices, is like any one of these things like overpriced compared to everything else? That's kind of tough. So we can create a scatter plot, and we're going to put mileage on the x-axis, price on the y-axis, and we expect to see kind of this, what we would call a negative trend, where vehicles with low mileage, we expect to have higher price. Vehicles with high mileage, we expect to have lower price. And then I'm also going to color them based on what year, maybe the trim level. And this is kind of what we see. All right. And so now that we see this, then we say, oh, this one right here. This one right here seems like it's a standout. It's like, why is this one so much higher priced than we might expect? Okay, based on this price, we would expect its mileage to be under 40,000, but this has like close to 70,000 miles, and it's priced quite high compared to everything else, right? So now that you graph it, now it stands out. Okay, so what's going on here? Okay, if I plot based on year, or if I color the dots based on year, it's, the difference, why this one stands out, it's a little bit hard to notice. Okay, what we do see is like the ones that are newer have less mileage, and the ones that are in 2019 maybe have more mileage. But here, if I color by trim line, we see, oh, this is the one vehicle that's in the R line trim. Okay, and if you look into it, the R line is kind of the Volkswagen performance, sporty, like bigger engine, more horsepower. I don't know what they do. Maybe it's supercharged or something. Okay, and that kind of explains why it costs more than all of these. All of these other ones are S trim. I don't even know what that means. Okay, but that's what we have. Okay, so the point of data visualization is that our brain can spot trends and patterns and unusual observations visually easier than it can when you're looking just straight at the numbers. Okay, so that's why we like to visualize stuff. Okay, the question is, how do we make a data graphic compelling? Okay, and yeah, anyone can make a data graphic. Is your data graphic compelling? That's a little bit trickier, right? It's kind of just like anyone can write poetry, but does your poetry evoke the desired emotion in your reader? That's a lot harder. Okay, and so as far as making a compelling data graphic, you really want to put yourself in the viewer's shoes, the person who's going to be looking at the data graphic, and you want to ask yourself, what is the key idea that I want to convey to the viewer? What is it that I want the viewer to see? Okay, and there might be a few different things, right? Do you want to show a general trend or pattern? Is that just kind of the point? Or is the point to show that there's a difference between some of the groups in your data, and you want to try to point out that, hey, this group is quite a bit different from everybody else? Okay, or maybe your graphic you want to bring attention to a single observation. You might want to say, hey, look, everybody else fits this thing, and this is the one that's kind of standing out, right? And so this is kind of, so there's so this one kind of shows the general trend, and it also brings attention to a unusual observation. And so, this is kind of like, you can show like historically, this is what the kinds of policies or things like this. And this is, this one, I don't know, this one athlete really stands out and is like truly a remarkable athlete compared to everybody else in history or something like that, right? So, and you know, obviously you're not limited to just these things, but these are some big ideas that you can kind of do. And then once you have this idea in mind, design your graphic around that. Okay. Graphics are also a great way to kind of just explore your data. And we have that. Okay, so I'm going to work through an example here. I do want to point out, and I do want to encourage you to do your textbook reading as well. And so there is in Chapter 2 of Modern Data Science with R, Chapter 2 talks a lot about this, and read through the narrative, okay, of this thing. And this goes through an example of federal elections in 2012, which is like, I don't know, I guess 13 years ago, and it seems like a lifetime ago as far as like politics and stuff. And but this was when President Obama was running for re-election, and his challenger was Mitt Romney. And anyway, there's kind of a lot of analysis regarding how much money was spent for a particular candidate against a particular candidate, like positive campaign ads, negative campaign ads, and there's kind of different questions. And so read through the narrative and the explanation, look at the graphics, and just try to make sure you can understand whatever point the authors are trying to make, which is really like, if you look at just one thing, okay, if you just look at one thing without further analysis, you might miss some key ideas. Okay, so here it's just like how much money was spent on each candidate, and you just see different amounts, and that doesn't tell the whole story, because over here, if you actually highlight, was the money spent on that candidate for the candidate or against the candidate, okay, and if you look closely, there was actually more money spent supporting Mitt Romney than there was money spent supporting Barack Obama at the time. But there was a lot more money spent on negative campaign ads against Barack Obama than there was against Mitt Romney and things like that, right? So when you kind of take further details and you break it down in terms of different categories and stuff like that, or you split it up in different ways, then it reveals a little bit more to the story. Okay, but anyway, that's covered in your textbook. So just make sure you do your reading. Here we're going to kind of work through the construction of a data visualization, and we'll work through constructing a scatter plot, and I'll just kind of talk about some of the elements that that will go into it. Okay, so in this case, we are going to load two packages. One is the Palmer Penguins package. This contains the data on penguins, and then the other is a library called ggthemes, which kind of brings in some visual and color themes and things like that. And again, anytime, if you don't have to follow along, but if you do try to run some of these codes and you run into an error message like this, error in library ggthemes, there's no package called ggthemes or something like that, that means you need to install it, okay? And so you just do install that packages, in quotes, the name of the package, ggthemes. But again, be sure to run it in the console, and don't put this command in your script or your Corridor document, because then it will reinstall the package every single time you run your script, and we don't want to do that. It's a one-time thing, okay? Anyway, this is the data set. You can just type in the name of the data set, in this case penguins, and it will print out the data set here. And let me pull up Palmer Penguins. Palmer Penguins. The Google search. This is our our package here. And then, so we have different species of penguins, and I just like showing pictures. So, they're just babies. These are no, these are full-grown Adelie. I don't know, Adelie. How do you pronounce this? Adelie penguin. Okay. And then yeah, they're cute. I don't know. Is there an ugly penguin? Okay, and then we have chin strap penguins, and these ones have a little like marking on their chin, so that's why they're called the chin strap penguins. And then you have the Gen 2 penguin. So we're looking at these different penguins here, okay? And then as far as the data collected, okay, they have things like the mass. All right, that's easy. You just put the penguin on a scale, okay? And then you have the flipper length. So it's kind of like it's the length of its, I don't know, we call these things arms. They're flippers. And then they also have the bill length and bill depth. And so looking at kind of the beak, okay? And so that's the some of the variables included in our data set here. Okay. We also, so we have the species of the penguin. There's 3 different species. There's different islands where they collected this. And so they're all in Antarctica, and no surprise. Okay. Let's see. So I don't know. It's too bad Antarctica's at the South Pole, but because it looks like there's some, could be interesting stuff here. But anyway, it's too cold down there. And so anyway, this is one of the islands. There's other islands where the penguins live. Okay. So we got bill length, bill depth, flipper length, body mass, and then 1, 2, 3, 4, 5, 6. There's other. Where are the other variables? There's the sex of the penguin, and and the year in which it was collected. Okay, so we have the species, island, where it was, Bisco Island and Dream Island as well, flipper length, body mass, sex, and year. Okay. So these are some of the different variables collected. And we'll start by just saying, hey, I want to set up a visualization. And so the function we use is ggplot. And with ggplot, we specify our data set, okay? And so if I do ggplot data equals penguins, R produces a plot, but with absolutely nothing. Okay, it just creates an empty plot, but R has basically said, all right, I understand you want to make a plot. But it doesn't know what to put on any of the axes, so it's just completely blank. Okay, and so the first thing we'll do is we will specify what at least 2 aesthetics. Okay, we're going to say I want to put the variable flipper length on the x-axis, and I want to put body mass on the y-axis, okay? Because maybe we want to see if there's some kind of relationship between the length of the flippers and how heavy the bird is, okay? And so, it's kind of like for humans, the length of your arms is highly related to your height. And in general, taller people weigh more, and in general, shorter people weigh less. And so what that implies would be, in general, people with longer arms will be taller and weigh more, and people with shorter arms, in general, will be shorter and weigh less. And we're just asking, hey, does that some kind of relationship also exist with penguins? And so we're going to say, hey, we're still going to be using the penguins data, and now we've given it an aesthetic mapping where you say flipper length goes to X, body mass goes to Y. sometimes you're going to see data and mapping like not typed out. So in the beginning, I'm explicitly typing out data equals penguins, mapping equals AES. Okay, but all ggplot commands, like anything that does a ggplot, will always have data and an aesthetic mapping. Okay, otherwise it's not a data visualization. So ggplot's first two things that it's expecting will always be data and a mapping. So if you don't say data equals penguins, and if you just say ggplot penguins, it's going to understand penguins is the data. And then the second thing will be the AES, the aesthetics, and it's going to understand that that's the mapping. Okay, so sometimes you'll see data and mapping left off, but that's because ggplot's always expecting these two things as the first two things. Okay, so anyway, when you do data equals penguins and AES equals this, then it establishes the plot, and it gets cut off here. So, it also got cut off here. But basically now it has put body mass on the y-axis, and then, sorry, it got cut off. Flipper length would show up along the x-axis. And ggplot automatically kind of sets axes numbers, okay? But it doesn't put anything on here, and that's because it doesn't know what geometric object we want to do, okay? We're going to do a scatter plot, so we're going to use points or dots to kind of represent each observation. So we have, how many? Let me just do library. So tidyverse, I'll load this up. Library Palmer penguins, okay. So we've got 344 observations in our data. And so how are we going to represent these things? We're going to create a scatter plot. And so we're going to use points, okay? And we're going to use geom underscore point. But in some, depending on the graphic you're going to create, you might want to have bars, okay? And so, you know, earlier we saw like the political spending things, and we had like bars representing the amount of money spent, okay? Sometimes you, like if you imagine like stock market stuff, you have like a line kind of connecting, you know, the closing price on each day on a stock, okay? And so you can represent things with lines, okay? Later on, I'll introduce box plots and stuff. And there's a whole bunch of different kinds of what we call geoms or geometric objects. And you can always go to ggplot. All right, if you search ggplot, the first hit should be the ggplot2.tidyverse.org. This is the kind of the reference website. And if you go to reference, it will show basically all of the different kinds of geometric objects, okay? So you have geom bar, geom box plot, contour, density, dot plot, function, all kinds of stuff. And they have little kind of snapshots of this, of each of these things. I think under, where's the cheat sheet? Okay, there is a ggplot cheat sheet, which, here it is. So the cheat sheet includes little examples of some of the different geoms, okay? So you can have, you know, line segments and scatter plots and blah, 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 right? So so this is handy as far as, you know, producing plots. But anyway, right now it's empty, and we want to add points. So we'll do that, okay? And so the command, here we've got penguins as our data. Our mapping is still flipper length on the X and body mass on the thing. And then we're going to add geom points. And ta-da, here is our plot. Okay, we have flipper length on the X-axis, body mass here, And now we've plotted all of our penguins, and we do indeed see a positive relationship. Penguins with longer flippers tend to weigh more. Penguins with shorter flippers tend to weigh less. Okay, and as far as the mass, the axes, the lightest penguin is around 3 kilograms, and the heaviest is around 6 kilograms, 3,000 grams to 6,000 grams. Whereas as far as the length goes, the shortest flippers are 17.5 centimeters. So what's that, around 6-7 inches? And the longest being 23 centimeters. Okay, 230 millimeters. So I don't know what that is. 10 inches. Okay, something around there. And this is kind of the relationship there. Okay. Anytime you see a scatter plot with just all of your dots, a question that is always relevant is, can I do some kind of subgroup analysis? If I kept in mind some of the different subgroups that exist. So in our case, we could look at the different species of penguin. Am I going to see the same relationship hold up for all of the subgroups, or will some of the subgroups have different relationships? Okay, or you could do split it based on the sex of the penguin, or I don't know, whatever. But basically, any kind of trend that might exist overall in the entire group, it might behave a little bit differently for some of the subgroups or all of the subgroups. And so, a subgroup analysis is very frequently relevant. Sometimes the same kind of trend holds up for all subgroups, and that's also interesting in of itself. Okay, that's kind of like your default expectation, is that the same trend holds up for all subgroups, but that's interesting of itself. But I think it's especially interesting if a trend holds up for most subgroups, but like one or two particular subgroups, the trend is reversed or opposite or something like that. And so, so we can say, hey, does this relationship between flipper length and body mass, is that different at all for any of our species? Okay, so we are going to include an aesthetic mapping to include for the species, right? And so we're going to extend our mapping, and so we still have flipper length on X and body mass on Y, but now I'm going to start coloring my dots based on the species. So we're just adding, one line of code here, all right, to this, and so now it has colored our dots based on the species. Okay, and so this reveals something, and this says, oh, one thing is we see the Gen 2 penguins, or Gen 2, I don't know how to pronounce it, okay? They are kind of the heaviest and the ones with the longest flippers, okay? So we can see all of these heavy penguins, all right? They're all over here. They all have the kind of the longest penguins, longest flipper lengths, heaviest body mass, okay? Whereas the Adelie and the chinstrap penguins, kind of similar. There's a lot of overlap as far as the size and flipper length goes, okay? So we kind of see a distinction there. Oh, okay, let me give you, I'll go ahead and give you your first two view quiz answers today. Today is week 1 Friday. All right, first answer is A as in apple. And your second answer is E as in elephant. A as an apple and E as an elephant. Okay, we can add some trend lines, okay? And just try to say, hey, can we fit like a trend line overall describing the relationship between flipper length and body mass, okay? Can I fit kind of a trend line? And we have different options for this, but if you want to do that, okay, we call this a smoothing line, a smoothing curve. And so we're going to add Geom Smooth, okay? And you have different options. Geom Smooth will generally draw kind of like if you do it with no particular options, it will try to draw a smooth curve, which might have some bends and stuff in it. If you want a straight line, you use method equals LM, and this says, hey, I want just a straight line, a linear model. That's what the LM stands for. And so here, this part is exactly the same as before. Flipper length, body mass on Y, species on color. We're going to do geom point, that gives us the dots. And then geom smooth, method equals LM says add a straight line. Okay. And this is what we get. Okay. And so we get these three lines here, which is interesting. Okay, so we can see if we look at it separated by species, this line is a little bit steeper than the other two. Okay, so this one's a little bit. There's kind of a longer flippers. Yeah, I mean there's a lot of scat, right? You have a lot of penguins, all with the same flipper length, right? So this when you see a vertical line of dots here, all of these penguins have flipper lengths of 215 millimeters, and you know this penguin weighed a lot more, and this penguin weighed a lot less. All right, here are penguins all with the same flipper length, 216 millimeters, and this one weighs a lot less. Stuff like that. So we have a lot of kind of scatter, but you know overall slightly steeper. These ones slightly. These ones have almost like the same slope, but just in general, the Adelie penguins, for the penguins of the same flipper length, tend to weigh just a little bit more. I don't know how much of a difference this is. 200 grams more? I don't know. Okay, so this is what we get when we have when we add geom smooth here. Okay. Now, depending on your analysis and depending on your graphic and what it is you want to display, okay, rather than having a separate trend line for each species, maybe you want one trend line for the entire data set. Okay, so I'm going to flip back several slides, but what if we just wanted one trend line to fit the entire data set? Okay, so you might want to do that. And again, there's nothing inherently wrong or right about this kind of graphic, okay? Or there's nothing inherently wrong or right about a graphic where there's just one trend line. It's just, what is it that I'm trying to do? But let's say you wanted just one trend line for the entire data set. You still want it colored by different points, but you want the trend line, you just want one. You don't want three separate of them. Okay? How would we do something like that? Okay? So we have to think about where to put our aesthetic mappings. Okay? When you put an aesthetic mapping inside the command here for ggplot, and you say X is this, Y is this, and color is this, these mappings, we say, gets inherited or passed down to all of the geometries. Okay? So our points will have X, Y, and color. Okay? And then geom smooth will also have X, Y, and color. Right? And that's why we have three different things here. Okay? If we want to keep the colors for the dots, we want to have colors equal to species for the points. But if we don't want to have three separate colors for the smoothing line, we don't want color species to get passed down to smooth. Okay, so to handle the desire to have an overall trend line, okay, I'm going to put in the ggplot mapping, I'm going to put X and Y only. All right, so X and Y mapping will get passed to point and will get passed down to smooth. But I'm going to put the mapping of color equals species only to the point geometry. Okay, and so the colors equals species here doesn't get passed down to smooth. And so if we do that, now we have the different colored dots, and we have one line for the entire data set. Okay, does that kind of make sense? The how we're separating out kind of the different layers and where the mappings go and stuff like that. So again, you might be in a situation where you want this. Oh, what happened? My computer froze. Okay, hang on. Sorry. Okay, so you might want this, or you might want this, okay, depending on your situation. All right, we can add a few other tweaks. So in this case, if I want the shape for different species, so here species is going to be represented by color and shape. And so now we have red circles and green triangles and blue squares. And, you know, I don't think our eyes notice the shape all that much. But, you know, if you're printing something in like black and white or something, then, well, it'd still be kind of tough. But at least there's kind of like a secondary thing to notice. Okay. And then all of these things, like if you want to add like titles, additional labels, if you want to kind of refine this. So this just takes the column name, and you know the column name is named pretty well: body underscore mass underscore G, flipper underscore length underscore mm. That gives us a pretty good indication. But you might have another data set where the column names are not labeled as nicely. Okay, it just might say like mass, and it might just say length or something. Okay, and so here you can add labels. Okay, and that's, you add the labels layer. And so here you have options like, I want to put this on the title and a subtitle, and this on the x-axis and y-axis. And as far as labeling the color and shape things, we'll do that. Okay, so we get body mass and flipper length, dimensions for Adelie, Chinstrap, and Gen 2 penguins, things like that. And then scale color, colorblind just changes the colors so that it's easier if somebody has color blindness. It'll be easier for them to distinguish some of the colors, just because for a lot of people with color blindness, red and green look very, very similar. They just kind of look like brown. And so you can kind of change this. And so now we have more distinct colors. We have more informative labels, okay, and a title, and we have this, okay. And this is just kind of, you know, a plot that we've produced. Yes, question.
Yeah, is there any way to choose a specific color?
Yes, there is an option, and I'm not going to cover it today, but if you go to ggplot and you look at the reference, okay, you're going to go under scales, okay. So scales is choosing how to represent something from the data to the visual properties. So in terms of like, so, you know, scales make a lot of sense when we're talking about like, what should the scaling on the x-axis be, right? Do I want to, I don't know, have the x-axis, what are the x-axis limits and things like that. That's part of scales, okay? But also scales will include things like, what color do I represent to use to represent small numbers, and what color do I use to represent large numbers? or what color do I represent to use this category or that category. And so you have scale, color, things like that. I don't know. There's a whole bunch of different options. And then and this is, so again, we don't want to have AI do all of our thinking and all of the answers for us. Okay, but this is, I think, one of the times where AI is very useful. All right, as you ask, I'm creating a plot, and you prompt it. I'm creating a plot in ggplot2. I want to change the color for this category to this and that. What is the function I use? And it will probably point you to the right function, maybe even give you a little bit of code for that. Okay. AI is a tricky thing. We want to have the right balance between doing the thinking ourselves, so we learn it, okay, but also it is very efficient as far as like when you have a giant list of functions, trying to figure out exactly which function to use. It's very useful in saying like, this is the function you use, okay? And then so you can always say like, hey, don't give me the answer. I want to figure it out on my own. But anyway, that's that. Okay. This is kind of like a little side note. This I'm taking straight from the textbook, okay? And so, you know, if you do your textbook reading, Modern Data Science with R, Chapter 2, they also finish off the textbook importance of data graphics. So I'm taking this straight from the textbook as well. This is kind of trying to say like, when you have something important to communicate, you really want to make sure that is the, like, when you want your data graphic to be compelling so that the viewer picks up the thing that it is that you are trying to communicate. Okay. All right. So this I just copied straight from the textbook, but in 1986, there was the Space Shuttle Challenger, and there was a fatal accident that the space shuttle exploded on its during launch. Okay, and it was a national tragedy, I think, you know. And I don't know if you visited any of the kind of air and space museums. Like, I'm a big fan of space stuff. So, but anyway, you know, you visit like the Kennedy Space Center, any of the space centers, you know, there's usually a dedication and a memorial for the Challenger accident, the Columbia tragedies. But one thing about the Challenger accident is that the engineers noticed that there could be a problem. The problem was that the booster rockets had these rubber O-rings that kind of sealed off the solid fuel, and because it was rubber, the rubber became brittle when it was cold. And the shuttle was launched in a January morning where it was really cold, and the rubber became brittle, and it failed, and the booster rockets exploded, you know, killing everybody in the shuttle. And there were engineers that were aware of the problem. They recognized this thing, and they tried to communicate this, but you know, they failed at communicating kind of the urgency and the danger. Okay, and this was one of the graphics that they used to indicate some of the problems. Okay, it would be an example of a graphic that is not compelling. It is a graphic that doesn't communicate the point that the engineers were trying to make. Okay, it contains the data, right? And the data is, they have the different temperatures. This is data showing past rocket launches. Okay, and they noticed that when it was colder, okay, that the booster rockets came back with some damage to the O-rings. And so they used this, and they said, hey, This is the temperature when it was launched. And then if you notice any of these kind of things, this is where the booster rockets were damaged, okay? And so kind of the key piece is right here that says when it was launched at 53 degrees, the rocket came back, the booster rockets, both of the boosters showed damage, okay? At this point, nothing had exploded, but they said this is kind of an indication that there could be some problems, okay? And these ones, there were no damage and things like that. Okay, and then there was also kind of a table of data. And again, we know that when you just see tables of data, it's hard to recognize points and things that are noticeable, okay? So Edward Tufte is a person who kind of studied data visualization. He's actually, he wrote these kind of books, like the Bibles of data visualization and like how to kind of communicate with your graphics. And he said, a scatter plot could have been a much more compelling way to display this, okay? Not using this kind of, the problem with this is that there's too much detail, okay? Sometimes you're like, oh, I want to include as much information and as much detail as I want. But when you have too much detail, the brain gets distracted and can't figure out what's important, right? It says like, oh, this was rocket booster, like there's pairs of rocket boosters, and it's like this was booster rocket A and booster rocket B, and it kind of points out all of these things. Too much detail, we get the information gets lost. Okay, this is a much simpler graphic. Okay, and over here we have each dot here represents a different rocket launch. Okay. And rather than trying to show the exact location where the damage was, just give it an indication, okay? Less damage is like 0, more damage, higher number, okay? And so the one that had the highest amount of damage, okay, was rocket 15, launch 15, and it had the most amount of damage, and that was at kind of the coldest temperature launch at that point, which was 53 degrees. Okay, and so this kind of indicates kind of a stronger trend. Warmer temperatures, less damage. Sure, there's some indications of damage, but then whenever it was below 60 degrees, okay, there were only 3 launches so far where it was below 60 degrees, but the ones below 60 definitely displayed damage, and then the one at the coldest definitely displayed the most amount of damage. Okay, so this is kind of the data so far. And then if you take that into account and you say, all right, what was the temperature on the morning of the shuttle disaster? The temperature was, it is literally off the charts on this one, okay? And the temperature was way down here, below 30 degrees, okay? 26, 29 degrees was the temperature of the morning. And so if you say, hey, just as a caution, let's try to imagine and extrapolate what kind of damage we would have if we extended this trend line out to here, we would see, potentially there would be a high risk of damage. And that was a potential thing. And so, I'm not saying like graphics are to blame here, but as far as trying to communicate the urgency, okay, this graphic doesn't do it, okay? And something a lot more simple and one where you say, hey, this is where changing the scale, and you say, I want to change the scale to include basically values that aren't part of my data, to kind of stress the point that this is where we're thinking of launching. And this is like uncharted territory. We've never done this. There's a worrying trend that as things get colder, there's a higher risk, maybe something like that. Okay. All right. That's it for today. Let me give you your third view quiz answer. Third view quiz answer is the letter B. B as in bear. B as in bear is your third view quiz answer. Okay, we'll end here. Have a great weekend. We'll see you on Monday. And if you guys have any issues with your stuff, let me know.